Our topic for today is converting from vertex form of quadratic equations into standard form. There's not really much to this, and it's really nothing new. You already know everything to do this, but I'll go through a few examples just to help get you comfortable with it. So vertex form, just as a refresher from yesterday, is in the form y equals a, where a tells us how wide or skinny the parabola is and whether it goes up or down, times x minus h, where h is the x coordinate of our vertex, so that's our horizontal shift, plus k, which is the y coordinate of our vertex, that's our vertical shift. Whereas standard form is the one that goes y equals ax squared plus bx plus c. Both of these have their uses, just like the different forms of linear equations, and we want to be able to go between them. So we're going to practice today starting with vertex form and going into standard form, and then if possible, even going into factored form. So that was the one that looks like y equals a plus b times something like that, right? It's not those things, but when we factor it, we're going to get some pieces out like that. So to start off, we have this equation for a in vertex form, and we want to turn it into standard. So to do that, we have to get rid of this x minus 6 squared thing. And we're going to do that by getting rid of the square and rewriting it as x minus 6 times x minus 6. The reason for that is we don't want to forget about our middle term that we're going to get that has x's. If we just do x minus 6 squared, the temptation is to do the first one squared and then the second one squared, but then we forget there's something in between those. So that's part of the answer, but writing it this way helps us make sure that we either do our double distribution or we do our area model so that we multiply correctly and don't miss part of it. And then we have here a minus 27. So I'm going to do double distribution for this one. So x times x times negative 6. That gives me, I'll go ahead and put that in green. That gives me x squared minus 6x. And then I distribute my minus 6 to the x and the minus 6. So I get minus 6x and plus 36. And then I still have originally my minus 27. So then finally I end up with y equals, I just have this 1x squared. Then I have my like terms of negative 6x and negative 6x. And then 36 minus 27 gives you 9. So same idea here. This one I'll go ahead and do the area model. So the important thing is we still get rid of this and we write out negative 3 times x plus 2 times x plus 2 minus 5. So now we want to go and figure out what is this part. We can do that with the area model. We draw the little boxes and we put x plus 2 and x plus 2. We get x squared, 2x, 2x, and 4. So I'm going to replace this with our trinomial here. So we have negative 3 times x squared plus 2x and 2x makes 4x plus 4, and then minus 5. Here we need to distribute this minus 3, so we're going to distribute that way, and we get negative 3x squared minus 12x minus 12 minus 5. So I just need to combine my two constants, and our final answer will be y equals negative 3x squared minus 12x minus 17. So you may have noticed as we expanded out these something x plus something or x minus something squared that we end up with always the same term in the middle twice. Sorry, the doorbell just rang. I was saying you may have noticed that whenever we square the x plus something or x minus something, we end up with a repeated term in the middle. So here we got minus 6x and minus 6x again. And then over here we got plus 2x and plus 2x again. So that's always going to happen when we square x plus something or x minus something. So you can definitely rewrite it and do double distribution or do the area model. There's also a shortcut that you can kind of like just know, is that if we have a plus b squared, that's always going to give us a result, kind of like our intuition said here, x squared and 36, right? We know we get a squared and we get b squared. But the part we tend to forget is that in the middle, this plus b times a and plus a times b will give us plus 2 times a times b. So we'll always get a squared plus 2ab plus b squared. So that happens every time that we have a plus b squared. Similarly, if we have a minus b squared, remember what happened here is we had minus 6's in the middle. So it's very similar. We still get a squared, and we still get b squared, and it's positive because we're squaring our 6 at the end, right? We had a plus 36. But then in the middle, we get minus 2ab. So these are little kind of just shortcut tricks that you can remember, but if you don't remember them, that's okay. I'm a fan of never memorizing things. So you don't have to memorize these. You can always just write out the thing side by side and do your double distribution, or write it out side by side and do your area model, and you'll come up with the exact same results, and it only takes just a few seconds more. But I know some of you really like the little tricks and have no issue with memorizing this and seeing that pattern, and a lot of you have probably already noticed that pattern as we've been going through the practice that we've done on polynomials. There's a third one in this set of tricks. It doesn't apply here because we're always doing something squared, but I always like to mention all three of them together. So the other one you may have noticed, that is if we have a plus b times a minus b, that's the situation where our middle terms are equal and opposite and they cancel out. So we end up with a squared minus b squared, and there's no ab term. There's nothing in the middle. So this one is called a difference of two squares. So these are three little just algebra polynomial tricks, quadratic tricks that some people like to memorize. You do not have to memorize any of them. You can always get these same results by just using the normal methods. Okay, so we have some of these for you to try. I'll do number 1 with you, and then if you want to pause and try some of the others, I'll just go through some. I probably won't go through all of them because you already know everything for how to do this. So this one, I'm going to go ahead on the first one and use the trick from up above and do y equals, and then I know x minus 2 squared is x squared minus 2 times ab. My coefficient of x is 1, so that's 2 times 1 times 2. So that's going to be minus 4x, and then we're going to have a plus negative 2 squared, which is 4. And then we have plus 3. So we get y equals x squared minus 4x plus 7. And then if we could, we might also be able to factor that. In this case, this one doesn't factor, so we won't be able to do any further work on this. So I'm going to go back to doing the double distribution model for the next one. So we have y equals x plus 1 times x plus 1. So remember, we get rid of that squared and actually explicitly write out x plus 1 times itself, and then minus 3. So doing my double distribution from x to x, x to 1, 1 to x, 1 to 1, I get y equals x squared plus x plus x plus 1. So those are the 4 terms I get out of my double distribution, minus 3. And then combining my like terms in the middle, we get y equals x squared plus 2x minus 2. So again, that one wouldn't factor, so we don't do anything else with it. And it doesn't ask us to here anyways. So go ahead and try 3, 4, 5, and 6 here. You can use double distribution or the area model or the shortcut trick, whatever you want to do. As long as you get to the right answer, it doesn't really matter which method gets you there. And then I'll go through these real quick if you've had a chance to try it. So if not, pause it. If you have, then I'll go through them just so you can check. So this is y equals, we have x squared plus 6x plus 9, but then we distribute the negative, so they're all negative. And then we have minus 9 and minus 3 more, so that'll be minus 12. Number 4, we have x squared minus 4x plus 4 is what we get by distributing or whatever. So we're going to distribute that half to those, so we get 1/2 x squared. Our middle term was minus 4x, so half of that is minus 2x. Our last term was plus 4, half of that is 2, minus 4 gives us a negative 2. Next one would be y equals x squared plus 2x plus 1, but all times negative 2. So we have minus 2 at the end plus 3, so plus 1. And I know I'm not showing all the work for this. I'm just trying to let you check the answers from you doing the work. So you should have worked all of these out already. This is y equals x squared plus 8x plus 16. We distribute that negative 3. So we had 8x times negative 3 is negative 24x. And then we had plus 16 times negative 3 is minus 48. Plus 1 would be minus 47. All right, so next section, we're just basically doing more practice of this. I'm going to do one from this section and leave the other 5 for you to try. So notice that in the instructions it says, if the standard form is not factorable, just like some of the ones we looked at up there, write does not factor instead of factoring it. So we can always go to standard form, but then they don't always factor into 2 nice clean linear factors. So let's distribute here. I'll go ahead and do the whole work for this one since it's the first one. So we're going to do x plus 5 squared. I did double distribution last time, so let's do the area model this time, just to mix it up. So we have x and 5, x and 5. That's x squared. Both of these will be 5x, and this will be 25. So we have this as our trinomial. That goes in place of this right here. We still have to multiply all of those things by 1/4 though. So I'm going to put that over here. We have 1/4, and then our trinomial is x squared plus 10x plus 25, and then we have a plus 2 on the end of that. So we need to get into standard form. Remember, we need ax squared plus bx plus c, meaning that we can't have this 1/4 or this plus 2 over here. We've got to incorporate everything together into a single simplified trinomial. So we'll distribute the 1/4. So we're going to have our standard form 1/4 x squared plus our middle term will be 10x over 4. We can simplify that though and make it 5 over 2x, so 5/2 x. And then we have plus 25 over 4, but then we also have a plus 2. Remember that to combine a whole number and a fraction, we have to express this whole number in terms of fourths in this case, so in terms of that fraction. So instead of plus 2, we're going to say plus 8 over 4. So we took the 2 and we multiplied it times 4 over 4, which is 1, so that doesn't change it. So now we can add these two because they have the same denominator. So our constant is 33 over 4. I'd like to write that stacked up, but this is kind of a small space to write it in. All right, so then we want to look at whether this is going to factor. And remember that factoring requires us to have all integer values, right? We can't have any fractions or decimals once we factor. So the fact that this is 1/4 x squared, if you think about putting that in our area model, and we put x squared over 4, there's nothing we can multiply to make that is not going to be a fraction as well. So there's absolutely no way we can create these fractions if we're just multiplying integers together. So here we're going to put does not factor. All right, I'm going to do one more with you just so we can see if the next one does factor. I'm going to do the first part a little quick, so I'm just going to go straight to the standard form really quickly and do 3 times x squared minus 2x plus 1 minus 3. So that's 3x squared minus 6x plus 3 minus 3. So we just have 3x squared minus 6x, it looks like, as our standard. And then we want to factor that. So think about how we can factor this. It's not a trinomial, it doesn't have a constant here. So we're probably not multiplying two binomials. We can't get rid of our constant doing that, right? Our bottom right box in our area model is never a 0 because we would need a 0 here or here to make that happen. So we can't make two binomials, but we can find a GCF, or a greatest common factor. So if we look at our 3 and our 6, we can factor out a 3. And if we look at our x squared and our x, we can factor out x to the first power. So dividing what's left, 3x squared, if we take 3x out of that, leaves us with just x. Minus, if we take 3x out of 6x by dividing, we're left with just 2. So this one did factor. It didn't factor into binomials, it just factored into a GCF, but that's okay, that's still factoring. So that's an important difference, that even though we can't come up with two binomials, we don't put does not factor because there was a GCF there. So I'm going to leave the remaining 4 for you to do and try on your own. You should know everything for how to do this, so it shouldn't be a big deal.